Okay, so let's start with the question today's session. The question is, what is the small file problem? What is the small file problem in Hadoop? What is the small file problem in Hadoop? You'll be hearing this kind of questions in interview. And what is up?
Aware,
Yeah,
yeah, if you create a small files like more small files, for each and every file we need to maintain a metadata, right? That means
exactly.
name node need to maintain all this metadata. So if you create more metadata, if you create more small files means it's obviously burden to metadata.
Very good. Not burden to metadata, burden to name node. Okay, very good
Yeah,
answer.
that's all. Sorry, burden to name node.
Yeah, very good answer. Very good answer. Yeah. So let me explain you what is a small file problem. Let me, yeah. So the small file problem is Hadoop says that you store small number of large files instead of storing large number of small files. What does it mean? Let's assume that I have a file 1 which is 100 MB file, 100 MB file, and there are file 2 which is 1 MB, and I have a file 3 which is also 1 MB. I have file 4 which is also 1 MB, and so on. I have file 99 which is 1 MB. Okay, in HDFS, as soon as you try to put the data into HDFS, what will happen? I have made a video for write operation also. If anyone missed it, please go ahead and visit that write operation, how the write operation will happen in the HDFS. So as soon as you execute your put command or copy from local or move from local command, your client will interact with the name node and request for the create a file and make an entry in the HDF, that metadata. So that information will be in the name node RAM. Let's see if I want to load this. Let's assume that my file size is 128 MB. My block size is 128 MB. Replication is 3. This is block. This is replication. Okay. Now, as soon as I say file 2, how many blocks it will get create? Block 1. What is the replication? 3. So, block 1 1, block 1 2. It means original block is there and duplicate blocks are there. So now this file has been divided into block, and this block 1 is stored into machine 1, machine 2, machine 3. It's like your file to block mapping, block to data node mapping. What is that? File to block mapping, and block to data node mapping. These two information will store in the name node RAM in the form of objects. That information will store in the your name node RAM in the form of objects. So each object will occupy, if you have a file, only one block it is there, it will occupy 150 bytes of memory. 150 bytes of memory. So if your file is a small file and it has only one block, it is a small block or bigger block, doesn't matter. If the file and it has one block, it will occupy in the name node 150 bytes of the memory in the name node. Now to store the file to, I need 150 bytes of memory. Yes or no guys? In the name node RAM? Yes or no? To store F3, I also need 150 bytes of memory. To store this file and so on. To store 100 files, it means I need 150 into 100, which is 15,000 bytes of memory I need to use for here 100 MB. Let's say here 100 MB. Yes or no? For small files, 100 files are there. Each file is 1 MB. The total it will be 100 MB. To store this 100 MB data into HDFS, I need to make use of 1500 bytes of memory of name node RAM. of name node RAM. I need to make use of your name node's RAM memory. How much? 150 bytes of memory for storing 100 MB file. So coming to bigger file. So this is the small file. Okay, coming to this 100 MB big file. So for this, how many blocks will come? Block 1 will come. And replication, let's take a block 2, block 3. Okay, and the block 1 is stored in machine 1, not block 1. These are duplicates, guys. It's actually, we should not say this as a, we should not say there's a block 2, block 3, because it's a block 1 only, and that block 1 I'm representing into machine 1, machine 2, machine 3. Now this information, again the file to block mapping, block to data node mapping will occupy how much of space? 150 bytes of memory. So here also I'm storing 100 MB file which is occupying only 150 bytes of memory in the name node RAM. Here also I'm making use of the 100 MB, which are the small files. It is occupying 15,000 of memory, 15,000 bytes of memory of name node. Which is better in this case?
Second one. No, I mean bigger
Bigger file,
one.
bigger file, right?
Yeah.
So this is called a
Yeah.
small file problem. Here the burden on the storage is fine. Your hard disk is same. Both will occupy the same space. But when it comes to the name node RAM, where it is maintaining the metadata information, that metadata information has become more for the small number of files. Small files, not small number of files, per small files. So how to avoid this problem? That is the reason Hadoop clearly says that Hadoop is mainly meant for the larger files. Hadoop is mainly meant for the larger file instead of small files. Do you guys understand the problem here? Others, please unmute and talk. We do not have any question and answer sessions. Whoever have a doubt, please talk that respective doubt.
Ravi, this 150 bytes is just an example, or it actually
No,
consumes this much of?
I have read in some of the source code. I mean, they occupy 150 bytes of memory. I have read it. So I mean, maybe some
Okay.
configuration also will be there. Not sure. Okay. So this is what happening for small files. How to solve the problem? How to solve the small file problem? So what is the problem? Small file. How to solve the small file? Okay. Someone has some doubt. Please go ahead.
Yeah, Veera, so one question here, and what is the criteria for a small file? It's a 1 MB, or is there any criteria like a 20 MB also we will consider as a small file?
No, lesser than block size.
Okay.
Lesser than a block size, I release a small file. Okay.
So our block size also should be optimum. Like block size also we can configure.
Exactly.
So yeah.
You can also configure your block size 32 MB or whatever the MB you want. You can configure based on that. Okay. Now,
So Ravi, another disadvantage can be like in case of input split. Like I was going through your
no,
MapReduce tutorial.
I'm not at come that point. I'm going to explain that.
Okay.
I'll
Okay.
tell you that. Okay. So this is the
Yeah.
problem. This is the problem of the storage. Okay. This is the problem of the storage. The first case one. This is problem with the storage. We found some problem with the storage. Case 2 is, I mean, point 2 is processing also some problem. Processing also has some problem. Processing also has some problem. What is the problem with the processing? Normally, I think we not yet seen the MapReduce. People may get confused if I start explaining the MapReduce, but I'll tell very high level. Okay, very high level. It's very high level. Don't worry about it. So whenever you have a one small block, right? So ideally, it is a text file. Whatever you have a block, those many map tasks will be launched. So you may get confused. What is a map task? We'll have a detailed discussion about the MapReduce. So now going forward, and I'll show some of the sessions. Okay, there is something called, so you have a small blocks, right? Each block will get processed by one map task. Each block will get processed by one map task. Here in this case we have 100 blocks are there. It means we need 100 mappers to process all this data. To process 100 MB data, we need 100 mappers because there are small files. Each file is one block. 100 mappers are required. It means 100 mappers, 100 resources are required. In your machine, in your cluster, it is occupying 100 mapper slots, or you can, if you anyway Hadoop 2 does not have Hadoop 2 onwards, we do not have anything slots and all, but it is occupying those many tasks and those many processes of memory, right, to process the small files. But the same 100 MB file here, it can be processed with a single mapper because it's lesser than the block size. Input split will come into picture. I'm not talking about input split here because if I start explaining input split, I need to explain input format. So then input split, then in record reader, all those things I need to explain. So but it's not a good right time to explain all about them. You just think if we have one block, one mapper will launch, but ideally one input split equal to one mapper. The formula is, it's not a formula, I can say in this way, number of input split. So what is input split? Input split is a logical representation of a block or logical representation of a data. It's not a block, logical representation of the chunk of data. Okay, so we'll have a detailed discussion about it. Don't not to worry, because without having this knowledge we cannot jump to Spark. So I'll be explaining these details. Number of input splits equal to number of mappers. Okay, this is the formula, guys. So but for time being, to make you understand, I'm telling that number of blocks equal to number of mappers. Why? Because I'm making use of the text input format. So I'm using the text input format. That's why I just said this is the number of mappers equal to number of blocks. So but actual formula is this: number of input splits equal to number of mappers. Ideally one input split equal to one block here. Okay, we'll talk a detailed discussion about later. Here when it comes to process this 100 MB, I need only one resource, but here I need 100 resource. Let's assume that my system has only 20 mappers, and rest of the 80 mappers has to wait to finish this task. It has to launch later. Okay, so this is a small file problem. How to solve this small file problem? So one is with a storage respective, other one is process respective. One is with a storage respective, other one is process respective. So how to solve this problem? Anyone? Any idea? Any guess? So if someone knows, good, well and good, or if someone can guess it. So how much we can try? How we can solve the problem?
We can optimize the block size.
Can I have this one?
Okay. So case one. So I'm asking solution for storage. Solution in that case one is for storage. So what we can do? We can compress the data.
Just merging all the data.
Okay. We can compress the data. We can compress is nothing, ideally it's archive, or you can use some compression techniques. So you can keep all into one file or directory, you can compress. Ideally compressing is nothing but one type of technique which is called archive. Your Hadoop has something called Hadoop archive. Hadoop has something called Hadoop archive. Archiving. So archiving is not a new concept here. It is there already. It's there available in the other, even in a traditional approach also we have something called archive. Whichever the data you are not used for the long time, or whichever the data you are not going to use currently, or very in the present, you can go ahead and go do the archive. The other one is from the small files making create of the bigger file. I mean merging and creating another file. So creating another file is a different ways are there. You can create using sequence file. You can create something called sequence file. So here we need to understand what is a sequence file. Sequence file is a different kind of file format. The file will be in the form of key value pair. The extension of the file will be .seq. Okay, the file will be like this. You can create from the small files, you create a bigger file. Like create a new sequence file or create a merge file, you merge it a single file. Either you merge all the small files and keep it as a one big file, or you can keep all this out of the small files you create a one sequence file. So this is how when we do this, the storage, when you merge it and when you keep it like this, storage will be solved. How? This is single file, this is also archive, also single file, so block will be 100 MB, the size of the file will be 100 MB only. Ideally when you archive it will reduce less, so it will be 100 MB only. So when you say 100 MB, it will occupy 150 bytes of memory in the RAM, name node RAM. And here also when you merge it all the small files with a sequence file, how you can merge? Your key can be a file name. I'm just giving an example, it's not always, okay? Key can be file name, your value can be content of the file. Your key can be null also, guys. If you don't want the maintain the file name, you can say null also, okay? Your key can be null, okay? So when you create a file like this, it will also size will be 100 MB, and it will also,
But only one key can be null, right?
is no constraint like that. There is no constraint like
And
that.
then how will we come to know that this content belong to which file?
Sorry, could you please repeat? So that's what, if you are making, so if you want to maintain this content is belong to this file, you have to maintain the file name and the key. So what I'm trying to say, if key can be, key can have some value or key can be null, no problem in it. If
Okay,
you,
and key can have any value,
it can have any
file
value.
name or whatever.
Yes, that's what I'm trying to say.
Oh, all right.
So it will also occupy 100 MB only, either that or this. Here also the space of the your name node RAM will be less.
Yeah,
Okay,
and it will occupy a little more than 100 MB, isn't it? Because the size taken by 100 keys will be additional, isn't it?
very less it will be changed. It won't be huge.
Yeah,
Okay.
that's correct.
Even your archive also will increase some space, okay? If you take 100 small files, your archive also improve because it will maintain something called index files inside. We will talk about that, okay? Here, at least we are saving, we are solving the line offset number 0 or null. So Deepika, I didn't get this point. Could you please tell what is the line offset number you're talking about? Okay. So here we are solving in this way, right? For the storage we can solve like this. In this case, what will happen? So storage means your name node reference, guys. I'm not talking about HDFS storage, okay? I'm not talking about HDFS storage. HDFS storage anyway it will occupy the, even the small files or bigger files, it will occupy the same hard disk space only. But your name node metadata information I'm talking about here, clearly try to understand. Storage means your name node RAM, okay? Coming to the process, case 2, processing. As we explained before, as we explained before, processing also we have some problem because multiple mappers are launching. So then how we can do? So one is the sequence file input format. Sequence file input format. Because if your data is there in the sequence file, you can use the sequence file input format. You can use the sequence file input format, which will launch only one mapper because your file is lesser. Your file will launch. I mean, the mapper will be launched only one mapper in that. If you have the bigger file, it will launch multiple mappers. We'll talk about that later. Here you are using sequence file input format because it's a single file. Single file is comes within the range of your block, so it will launch only one file, one mapper. Okay. And second one is there is something called combined file input format in combined file input format. Combined file input format in MapReduce. What it will do, in this case, what we need to do, we need to keep all the small files in one directory, and we'll give the directory as an input to your mapper on your MapReduce framework. What will happen in that case? We will specify our input split size. will specify input split size. So what is input split size? As I said before, it is a logical representation of piece of the data which will process by single mapper. Okay, input split, guys, it's the most important entry question. What is input split? People will be asking you. Keep it is a logical representation of a piece of data, which will process by a single mapper, a chunk of data, you can say. It is a logical representation of chunk of data which will be processed by single mapper. So here in this input split size, we will define what is my minimum, what is my maximum input split size. So let's say here my input split size maximum I defined 128 MB. What it will do when it's trying to process the data, it will collect all the small files, it will try to put into single mapper. It means it will try to process by single input split, like it will create a single input split. In the single input split only, it's not like a physically, guys, it's logically. It means all small files will be read by single mapper. All small files will be read single mapper. Here one problem is there. Here we have one problem. What is the problem? Because here all the files, right, should be same type of file, should be same type of file. What does that mean? Let's say my file 2 is a text file, my file 3 is a key value pair, tab separated, some type of file 3, and file 4 is some sequence file 5 is some different file. So if XML file and some CSV file, if you take these kind of files, right, if you have different kind of files, so whatever the map logic you return, it will get processed, but you may end up with the wrong results, or you may end up with some exceptions. Okay, so when all files are the same type, then we'll go with the combined file input format. So this is how we will solve the small files problem. Any questions? Any questions?
Ravi, we can yeah, Ravi, Sharon this side.
Yeah,
We
go
can
ahead.
simply merge by using merge command in Unix.
That's what we are creating is a sequence file, no? By using get merge. That's what a sequence file.
Okay.
Either you create a sequence file or you create a bigger file by using get merge. I mean, you're creating a single file.
Okay.
Okay,
Fine.
here, actually not here. Make a single file.
Yeah, got it.
You can do with a get merge, or you can do with the Java code, you can do with some shell code, whatever that. You are making a single file. That is sequence file format, or you are making something else. Any other doubts, guys? Yeah.
For sequence file input format, the input should be dot sequence file or it should be any format.
It will be dot sequence file. The code what we write also, the mapper also, we will define my key is this type, my key is this type, like that.
Okay, then what is the difference of like sequence file input format and combined file input format?
Combined file input
Other than
format,
that,
in the combined file input format, you have to write all. Combined file input format is like a custom input file format. You have to specify what is your key and how you have to write. So what is your record reader, what is your input split, everything you have to write in your combined file input format. It is like a custom input format. It's just a parent class. That parent class you have to extend your own, and you have to specify how the file has to read in my code. You have to write your own input format.
okay.
Any other doubts, guys? Any doubts, guys? Anyway, this combined file input format and a sequence file input format, these things we will see as part of the MapReduce. So now we are going to see how to do a Hadoop archive. This is what we came for this, right? This is the command we need to execute. That's why we are here. That's why we come to this problem. Let's see what is that. Everyone is clear? Any doubts? Any doubts? No, very good. So let's go back to our terminal. First you need to identify what are the small files you have. What are the small files you have? First you need to identify the small files. Now I'm going to show you 26 or 27 small files. I'm going to do the archive out of it. Or if you feel that 26 27 files are very huge files, or you can find this 2 3 files which are there in the drive. Now let's start all the services because I want to start.
Veera, is archival is splittable?
No, it's not splittable.
Then like if you want to process the like for suppose if you want to process the small files though, so how can we process the files?
That's what I just explained. Either put it into sequence file or combine file and full format, or you make it a single file and do it. Archive is not, it's not a good, archive files will not never give to the MapReduce. I'll show you that how.
Okay.
Okay, now first I need to identify where and all my I can execute the command itself, right? Hadoop fs -ls / training 1 / capital R.
Capital R.
Yeah. Word count. Yep. Single map or word count. This is what I was looking for. I need this path. Okay, so let's see the syntax of your command hdfs. Just press enter. The command is, it is a hdfs command. Okay, not here, it is a Hadoop archive, right? Press enter. You have a Hadoop archive. Hadoop archive, and you need to specify this is also attribute. That's not the that is not optional. This is your attribute, and the name -p, your parent path, and source and destination. Create a Hadoop archive. So we'll create a Hadoop archive. Let's go ahead and let's see that how we'll execute. Hadoop archive name, and I'm telling that archive name as um, archive test dot har. Har is the extension for your Hadoop archive. P, this is my destination, I mean source, and I want to put into let me put into this entire under training itself. Small p. It's a case sensitive. I'll be confused with these things. What is trying to do? It's trying to connect resource manager. It means it's trying to launch a MapReduce job. So your archive job will launch a MapReduce job to archive your data. It's taking, I mean, wow, done, good. So let's go back here, localhost, and you can also look at here only, no? So you don't need to go inside that. You can also we have given archive test, and it has been created 27 today only, and 0. Why 0? Something went wrong because it's a directory. Let's see that. archive test. Yeah. So this is your part file. This is your part file. And look at this. This is the data from all other mappers. Actually, that was word count program. That was a very big word count program, and that was having a word and the counts. So this has been merged, and it's a single file. Okay, all small file, 27 files has been merged and it's made it as a single file. Okay, now let's go back.
Ravi,
Hmm.
Ravi, here one question like it launched MapReduce program.
Hmm.
Then this particular program also must have taken some input format, and this also has must have created input splits and everything, right?
So it's a default. It's
This
just like
particular
it's just a compressing, right? It's just a compressing technique, right? It's not like you're writing some map logic and reduce logic, right? Whatever the data are there in that, you're reading the data, you're merging into file.
Yes, yes. I mean, but any MapReduce program, like in the scope command also, when it converts into MapReduce, it by default it takes DB input format, and
Correct.
some input format it takes.
Correct.
So
Correct.
this particular MapReduce program also took any default input format.
So I think it will take default generic type. I really didn't get into seeing that detail. Let me make a note and I'll see that. I'll
Okay,
see that
yeah,
later.
okay, yeah, thank you.
Input format for, I think default text only it will take, I hope, because it will just read text only it will take. Offset it will take the key and complete rest of the thing it will take a text. Input format for
Yes, I
archive.
think so because it's combining the text
Yeah.
files.
It
Yeah.
just not only text file, if you give any type of files, it's just no need to worry what is my key and what is my value, because we are not going to do any
Yes.
aggregation over there, right? Look at here. When we look at here, in this, what are the files which has been compressed, it is showing you here, and it has like it's a directory and it's a your what the group is belong to. Underscore success file was also there, and part R file is file 1, file 2, and so on. These are all the files. Total 26 files, including 00, it's 27 files. It started with the 0, 27 files are there. And here if you see, if it is, this is inside the file, so you're inside HAR, you'll be having one is a part file, and you will be having something called the part file. The part file will contain all your merged data. Merged data will be there in this, okay? And your HAR, it will maintain index and master index, two files will be there. In the index file, it will represent, let's say here, so what are the files I have merged, no? So the file I should know, I mean, when you are processing this data, that you should know that where the file 1 is started and where it is ended. In the single file, in the single part file 0, what is the portion of the what is the portion or what is the content of which belong to the file 1? That information should be there, right? That information maintained by this was index file. Look at here, part 0 file. This one, part 00 file. Part 00 file, in the part 0 file, it is there, it started with a 0, and it is the length of the file, I mean in bytes. And the next file is this, started with the 273 and this, and length of this, and it will sum it. Okay, when you sum these two values, the next offset will start. See, the file 102 started with it started from the 0 offset, and this many bytes it has been occupied. Okay, now what will happen? It will merge. Okay, it will sum these two values. If it sum these two values, 2000, I mean 973, and this second file is there this much length, I mean this much size, and these two will be sum, and the next offset will start. So like that all the offsets will be merged and shown. This is how it will work. This is how your archive work. So here with the Hadoop archive, there are some limitations here. There are some limitations. What are they? What is the limitations of? What are the limitations of Hadoop archive? Very first limitation, disk size. Disk space. Very first time when I create an archive, my original file will be there. Original file is there and archive file also there. Both are there. So when we'll go for archive, when you have when you constraint of the space and you will go with the archive. So original file will be there as well as your archive file also, both will be occupying some space. You may say that, sir, once I archive, I will remove this. If I remove this, tomorrow if you want to add any file to this archive or you want to remove any file from this archive, it's not possible. You cannot do that. You cannot do that. Altering is called either add or remove is not possible with the archive. Altering the archive is not possible. These are all limitations of the archive.
Cannot we copy the data from the archive file to one text file? I mean, and then we can archive that particular text file.
It will be one file only, right? When you archive, I want to add a new file. I don't want to add the content. I want to add the new file.
Okay.
Please keep mute yourself, guys. Okay. Next, the third is your Hadoop archive files are not, your MapReduce is not aware of archive. It means your MapReduce is not aware of Hadoop archive. Not archive aware. I can say not aware of archives. What is awareness? When I say awareness, it means even though your archive is single file, even though your archive is a single file, it's supposed to single file, it has to launch single map only, no? Even though it is a single file, it has to launch, which is the archive file. Your what are the archive have given sample.archive, let's assume that har, even though it is a single file, you has to launch one mapper. But your MapReduce is not aware of this archive file. How many files has been archived? Those many mappers will be launched. Performance problem. Those many mappers will be launched. So multiple mappers will be launched. So these are the limitations of your archive. These are the limitations of archive.
So, I mean, Ravi, to overcome this, so that only single mapper is launched, can't we like take the content of the archive file and copy into one single file, and if we have one single file, then only one mapper will be launched?
That is nothing but this one, you know. That is nothing but this only, right? You're merging as a single file.
Yeah, but I mean, we can merge as a single file as a text file. Here we have sequence file,
That's
key
what.
value.
Here you can make
But
it a single file also. No, you can use the get merge command. Already one of our mate asked the same question, right? Here all the small files are there. You can make it instead of making a sequence file, you make a one text file and process that. Why you need to do
yeah,
archive? Why you need to do archive?
yes,
Then take out from the archive. Why you want to do all these things? So you
correct,
can,
correct.
right? Okay. So that is about archive, guys. That is about archive, Hadoop archive. Okay. That is about Hadoop archive. And let's see the next command is OIV. I will explain OIV. You guys need to execute offline image viewer. Offline image viewer. So whatever the Fsimage files, whatever the edit files you have in your setup, those are not the human readable format. Those are not human readable format. Guys, I did not yet get the call. If I get a call, I may get disconnect. If I didn't get the call till 10 o'clock, I'll extend 2 3 I mean 5 10 minutes. Okay. Slash usr local Hadoop, sorry, yarn data. Yeah, Hadoop yarn data HDFS name node current presenter. I'll be showing you for image file. You guys do it for edit file. The process is same, nothing changes. Okay, you guys do it for that. I want to view this file. Right click, edit, open with other application. You choose any other application here. You cannot view that file. You cannot view that file. Okay, so it's hanged. No, it's not hanged. Fine. Yeah, it's about to hang. You cannot view that file. Okay, now let's go back and convert this file and try to view this file, okay, which is in a human readable format, and try to convert this file and view the content of this file. So what is the command for this? So first, as I shown here, let's try to understand your syntax. OIV, okay, so HDFS OIV, and it expects the input and expects the output. Okay, let's look at here. Your offline image viewer, you had input path, you have to give input file which image file you want to process, and you have to give output path. Okay, and processor, I'll tell you what is a processor. The processor, like you want to make it in XML file format or file distribution or web, different kind of file formats, you can view the text. And H it hyphen help, it will display the help information, the whatever we have done, right? Just say that the same information will be displayed. Okay, so now we are going to take I and we are going to take output, and we are going to specify what type of format it is going to be. Okay, HDFS OIV hyphen I input, you need to specify what is input. So this will be my input, right? This will be my input slash fs. So I think it is 4. I think it is 4. Yeah, 1 4. So we're going to see that this is input file hyphen o output path, where you want to put into output path. So let me create a separate directory for you guys to show that detailed information. In the help already I have so many files, but let's create one directory. Create a directory here. Create a directory here. OIV. Okay, this is my output path. Slash USR local help OIV is this is my output directory. Here fs image dot xml and hyphen p, I'm representing what format it has to be. It has to be an XML format. Press enter.
To be here, the paths we have given belong to our local directory, not HDFS.
Why will give the HDFS? Where your FS image will be there?
No, the output path.
Output part, why you want to store in HDFS?
I mean, I'm confused because we are writing HDFS command. So, like,
HDFS command is not always you want to write. See, you are using HDFS get command where you are writing output. Does it mean that
I mean that.
your HDFS command you always write into HDFS only? No, right?
No. Yeah.
It's the same way here. Okay, let me show this, guys. The XML file has been created, so it is there in XML format. If I open the gedit, it looks very ugly, and this is what the original FS image. You will never understand anything from here, and this is like your XML file, and here also we are not able to understand properly. Let's open that file into browser. Always try to open your XML files into browser. It will display properly. Here you can see all your FS image and name selection. You have something called transaction ID and inode. Okay, let me say any file. This is the file, and this file has a replication factor is 1, and this is the time it has been created, and this is the block size. This is the block size. These are the user permissions, and these many blocks are there. These many blocks are there here. These are the blocks. These many blocks are there here. These many blocks are there. Okay, each block and its block size has been defined there. Okay, so this is about this is about Fsimage. You guys also try for edit log. Okay, very good question, Shaif, Shaif or Shaikh. So I recommend you to please go ahead and view my recordings of the CCA 175 recordings. So then you'll understand what is Fsimage and edit log. Okay, so now because it's too late to ask this question Fsimage, because Fsimage we have discussed in the second class or first class. Okay, so please go ahead and view that, and if you have any doubt, please you can ping me or can call me in my mobile. Okay, now the next command what was missing is getconf. Getconf getconf is a command to see any configuration value. You want to see any configuration value, you can use the getconf command. You may come across, they may ask that I want to see the configuration value, but I don't want to see through UI, or I don't want to see through our XML files, default XML files. So what is the command to see your XML, this one, configuration values? So here hdfs getconf hyphen conf key, you have to specify hyphen conf key, and you have to specify what is your configuration. dfs dot block size, this is my configuration, and just press enter. Block size dfs dot, no, what is the configuration name, guys? Dfs dot conf, let me try with replication. I forgot the configuration name. Replication, replication is 1. Maybe that's a this size, this wrong. Block size maybe smallest, yeah, smallest. See here, I'm able to fetch my replication factor from the terminal itself. I'm able to fetch my block size in the terminal itself. Okay, so that's it about this HDFS commands, guys. There is something called Hadoop job commands as well. So because I have seen one of our mate was asking in the chart window, you can also see here the job related commands. You can kill the jobs, you can check the failed tasks, you can list out all the jobs which are running. You can kill by specifying the job ID, you can find the counters, you can find the status, you can submit the job by using Hadoop job and hyphen submit command. If the Hadoop jar command is to execute the jar command, jar files, if you want something else kind of different jobs you want to execute Hadoop as a Hadoop job, you can use the Hadoop job command. Okay, so these are all about HDFS commands, and this is about HDFS in detail. And the next class we will be seeing either scoop or flume. I'll be posting you what we are going to discuss. I think probably we'll be discussing about what do you say, scoop. We'll discuss about scoop because those people are asking some questions from the scoop, and scoop and flume no relation with anything, so we can discuss separately, no problem. So yes, developer will have a permissions to execute the job, but killing I doubt whether he will have a access for the killing or not. Okay, you can see here, and let me show you my YouTube channel. Let's go to YouTube. I need to log in with a different name. These are the things my kid used to see, so that's why it is showing here as a recommendation. I will add account. Big data solution for you.
Ravi, what is the full form of OIV?
Offline image viewer.
Oh, okay.
Okay, here you can see the playlist. Okay, I think I don't know whether I have added in the playlist or not. So you guys can see the setup. Go to the setup. The setup. Okay, then it will be there in videos. MySQL and Scoop setup. I recommend you to guys go through this video to set up your MySQL. If anyone interested to set up for Flume, and I have a Flume setup along with an yeah, example Flume setup and Flume how to some example. So there are two videos are there. You guys can go through Flume and Hadoop setup. Please make sure that you guys have a setup by next class. We'll start doing some experiments in it. Okay, thank you guys. Thanks for your time. Have a great day. If you guys have any doubts, please quickly go ahead and raise your doubts, and else we can leave for the day. Any doubts?
Thank you, Ravi.
Yeah. Thank you guys. Thank you, Dheeraj.
Thanks.
Thank you, Ravi.
Yeah. Bye guys. Bye. Have a great evening.